Yes, I think so. We can start.
Can we start?
Sir?
Start. Hello.
Hello, sir. Sir, if
Listen,
you're ready, we can start.
am I audible?
Yes,
Yes,
sir,
sir,
you
you
are
are
audible.
audible.
If you are ready, we can start.
Yeah, I'm ready.
Okay, sir. Okay, sir. Yeah. Good afternoon, everyone. Welcome to this post-lunch session of day 4 of this workshop. We have among us Dr. Manas Pratim Burman, sir. He don't need any introduction because this is his third session with us. Uh, Initially, I would like to thank him for giving us a lot of his valuable time. Today, sir will be discussing on the topic inferential statistics using SPSS. Uh, Without speaking much, I would like to request sir to take over the session and continue. Sir.
Hello, everybody. Inferential statistics mean in inferential statistics we take decisions. Okay, decision about the population. In statistics, what we do, we suppose we need to study the population. We need to study. Suppose I need to study the marks of the students of Dibrugarh University. So this is my whole population. All the students of Dibrugarh University is my population. But suppose I don't have so much time to study each of individual. So what I do, so I take a sample. Okay. So in statistics, we always work with sample, not the whole. We never study the whole population. We take a sample and we study that sample. And based on that sample, we have to make decision about the whole population. And that is called the inferential statistics. Inference. We have to draw inference about the population based on the sample. Okay. And a very important part in inferential statistics is statistical test. Okay, now we are going to study about, I think Hazarika sir already told you about the inferential statistics. So I want to go how it can be done in SPSS. So one of the important components of inferential statistics is the statistical test. Now I will show you how to do different statistical tests, right, in this presentation. So statistical tests are basically divided into two parts. One is called parametric test, one is called non-parametric. Okay, so we have two forms of test. One is parametric, one is non-parametric. Parametric means has parameters. Okay, so I think Hazarika sir already told you about these things. So I don't want to take much time. So I have given the definition of parametric test. Parametric test is a hypothesis testing procedure used procedure based on the assumption that observed data are distributed according to some distribution of well-known form, that is normal. In simple way, we can say that we have to use parametric test when my data follows a very well-known distribution that is called normal distribution. If my data follows normal distribution, if the data that I have collected it follows normal distribution, then we have to apply parametric test. Otherwise, we have to go for non-parametric test. Okay. Why? Because all the formulas that are developed for parametric test are developed based on by considering that the data follows normal distribution. If your data does not follow normal distribution, then you should not apply non-parametric test. You have to make it very clear. Okay. So we cannot apply parametric test when my data follows normal distribution. Then only I have to use parametric test. Otherwise, I have to go for non-parametric test. So non-parametric test, there is a definition I have given. A non-parametric test is a hypothesis test where it is not necessary or and to specify the parametric form of the distribution. Okay, so in simple sense, we have to tell that we have to say that we have to apply parametric test when my data follows normal distribution, and when my data does not follow normal distribution, I have to go for non-parametric test. Okay, now the question arises: how do you know that my data follows normal distribution or not? That is the basic thing. Okay, we have to test whether my data follows normal distribution or not, right? So I'll give you some tests with the help of which you can study whether my data follows normal distribution or not. So this is about this. We have to assume some while testing hypothesis. We have to assume a hypothesis that is called null hypothesis. I think Hazarika sir already told these things about you about this null hypothesis and alternative hypothesis. So before conducting any statistical test, we have to consider a null hypothesis. Null means no, no difference. Okay, so we have to consider that all the things we have to study are equal. Okay, no difference. You see here the example first one. There is no difference in the mean systolic blood pressure level of male and female. Suppose I want to study whether the blood pressure level of male and female are equal or not, or different, or it is different. Suppose I want to study it. So the blood pressure level of male is same or different from females. So for that I have to go to the field and collect data and collect blood pressure level from males as well as females, right? Now from this, I have to, before going for statistical test, I have to consider a hypothesis, and I'll try to see whether that hypothesis is true or false by using that data. Okay, my hypothesis will be that there is no difference because it's a null hypothesis. That means there is no difference between blood pressure level of males and females. So we consider a hypothesis of no difference. An alternative hypothesis is a statement that contradicts to the null hypothesis. So here we have to consider that there is a difference, or the male blood pressure level is more than females, not equal. Okay, so first of all we have to consider a null hypothesis and also as well as the alternative hypothesis, and we are going to check whether my null hypothesis is true or false based on the data, right? Now uh, whether now for testing the statistics whether it is true or false, we have to use p-value. I think p-value already Hazarika sir told you about p-value. So the basic concept is that if your p-value, the p-value you got from the calculation, if your p-value is less than 0.05, then you have to reject the null hypothesis. Otherwise, you have to accept the null hypothesis. The basic is that the main concept is that if your p-value is less than 0.05, if you are going to study it for 5% level of significance, and if your p-value is less than 0.05, then you have to reject the null hypothesis. Otherwise, you have to accept it. Okay. So this is the p-value. If this is the actually this is whole area is 1. Whole area is 1. From here to here, the whole area is 1. Okay. From here to here, the whole area is 1. Now, p-value 5% means this is the 5% area of the whole area. So if it falls in this side, then the null hypothesis will be rejected, and otherwise the null hypothesis is accepted. This area is called critical region. If our t value statistics value fall in this portion, then we reject the null hypothesis. If it falls in the white side, then we accept the null hypothesis. Okay. Now, first question arises before going for statistical test. We have to check whether my data follows normal distribution or not. And for checking that normal distribution or not, we have certain plots and tests. Okay, so we can use some plots, graphs, or we can use Kolmogorov-Smirnov test for testing the normality of the data. Okay, I'll show you how to So these are plots are histogram, blocks plot, QQ plots. These are the plot with the help of which we can check the normality of the data. So this is a histogram, right? So you see, if your histogram shape like this, that means it is a symmetrical shape. Okay, this is a symmetrical shape. Then we can call it my data follows normal distribution. Now it is shaped. If this is shaped like this, this is called. This is not normal actually. This is symmetric, na? This is bell shape. It is shaped like a bell. So this type of is called symmetric or normal. So if your program shape like this, then this or this, then we can say that my data does not follow normal distribution. Okay, we can very easily construct it in SPSS. I'll show you. This histogram can be very easily constructed in SPSS. Suppose this is the age variable. Yesterday I told you about this database. I am using the same database. Okay, so this is the age data. Now I want to check whether my age data follows normal distribution or not. So for that I have to go to graph, legacy dialog, then histogram. Okay, then I put the age variable here. Okay, then click OK. It's very easy. I'll show you one more time. You go to this. Suppose this is the age variable, and we have to construct a histogram for this. You have to just go to graphs, legacy dialogs, then go to histogram. Okay. Then you select the variable and put it here. Select here and put it here and click OK. You will get the histogram. So I think it is appear now. And this is the histogram. See, is it like symmetrical? No. Okay. So this is histogram. It is not like a symmetrical graph. So it is like this. Like this. Okay. So it is. I think that my data or age data are not normal. Okay, not normally distributed. So I think you understand this. So with the help of histogram, we can very easily study whether my data follows normal distribution or not. This is the first plot, histogram. Okay, then we have another plot. This is a very famous plot. This is called blocks plot. Okay, this plot gives us a lot of information. Okay, so this is actually box. This is the box, and this yellow line is the median. If I arrange my data in ascending order, suppose this is my data range. From here to here is my data. Okay, so if I arrange the data in ascending order, suppose this is the lowest value, this is the second lowest, this is the third lowest, like this. This is the maximum value. If I plot like this, and this is the median. Median means the central value. Okay, this is the median of the data. This is the central value, and this is the first quartile and third quartile. Okay, and this box is the interquartile range. This box is called, the length of this box is called interquartile range. It is means Q3 minus Q1. I think you know about quartiles. Quartiles it is a measure of dispersion. Okay, so now these are the Q1 minus this is called whisker. From here to here, this, and from here to here, these are called whiskers. Okay, and whiskers is calculated by minimum means Q1. This is this minus 1.5 interquartile range. 1.5 into this area. So here we have to plot these values. Then again Q3 is Q3 plus 1.5 IQR. IQR interquartile range. Interquartile range means Q3 minus Q1. That means this area. So this whisker is calculated by Q1 minus 1.5 IQR, and here it is Q3 equal to Q3 plus 1.5 IQR. Now, if any points falls outside this are called outliers. I'll show you. I'll show you how to make this one. Is if some point falls outside this whiskers, then it is called outliers. Okay. If there are outliers in your data, then there is a possibility that your data does not follow normal distribution. So you have to see, study whether any outliers are there in my data. Outliers means extreme observation. Okay. Outliers means extreme observation. Extreme observations means suppose a student is getting, suppose I am collecting the marks from a students about 5 marks on 5 subjects. Suppose in mathematics he got 60, in science suppose he got 50, in suppose social studies he got 60, like this, and in suppose advanced mathematics he got 0. So 0 is a extreme observation. Okay, so this is called outliers. Okay, now you see, if your median in this, if your median lies in the middle of the position, then there is a chance that your data follows normal distribution. If it falls in the middle of the box, okay, then your data, there is a possibility that your data follows normal distribution. If it falls this side, then it is called positively skewed distribution. Skew means there are outliers. And if it falls this side of the distribution, this is called negatively skewed distribution. So by observing the box plot, you can have idea whether my data follows normal distribution or not. Yeah, so if your median value lies at the center of the box plot, then you can say that my data follows normal distribution. And if there is no outliers also, if there is no outliers and it falls middle of the distribution, then it is called normal. If it falls this side, then it is called positively skewed distribution. If it falls this side, then it is called negatively skewed distribution. Now, I will show you how to make box plot in SPSS. Suppose I am going to make a box plot for variable, suppose income. This variable. I want to see whether my data of income follows normal distribution or not. So for that, I have to go to analyze, graph, legacy dialog, then box plot. Okay, select. So we have simple box plot, we have cluster box plot. Okay, now we are going to calculate it for single box plot. Then you have to select this one, summaries for separate variables, summaries of separate variables. So select this, get defined. Okay, then income is my variable. So select income and give it. Okay, sorry. Let us try one more time. Legacy dialog, box plot, summaries group for, actually I think I should select this one, summaries for group of cases, defined. Then category axis, you have to put here. One minute. Okay. Okay, it will be like this: graphs, legacy dialog, box plot. Okay, then we have to calculate simple box plot. Then you have to select this one, summaries of separate variables. Okay, summaries of separate variables. Then defined. Then box, you have to put income in box represents. So what the box represent? So income. Click OK. So this is the box plot. Okay, it is. I have shown this box plot it is in a horizontal way, and then this box plot in vertical way. But there is no difference. It's the same. Here the data are arranged like this. Okay, so this is the median. 20,000 is the median, and this is the. You see, the median is in the center of the data. but there are certain outliers are there. So this suppose 269 observation is the outlier. Here observation number is given 157 number of observation is an outlier. So we can see 157 number of observation 157 157. So this is the 157 value. This is the 157 value. You see 76,000. It is much higher than the others. That means it is an extreme observation. So this is called an outlier. Okay. So some person here, that means in this data, some person are there whose whose income is very high than the others. Okay, very few people are there because you see there are very few people whose income is very much higher than the others. So there are extreme observations. So let us show you one more time how to make box plot. So let us make box plot for suppose age. Okay, so for that I have to go to graphs, legacy dialog, box plot. Okay, select it, then go to simple. Then we have to select this one, summaries of separate variables, then define. Okay, then suppose we want to find it for age. Select this age, define. You see here that there is no extreme observation. So there is a possibility that my data follows normal distribution in age, but this is not actually not median is not lies at the center. Okay, so this line is very high and this line is very small. So it is not lying in the center of the box. Okay, so there may be possibility that it does not follow normal distribution. Okay, I think you understand this. So for that, for constructing box plot, I again once more show you one more time. I have to go to graphs, legacy dialog, then box plot. Then I have to select simple, then summaries for separate variables, then define. Then I have to select the variable for which I want to construct the box plot. Suppose I want to construct it for BMI. Yesterday we have calculated BMI. So BMI. So click OK. This is a very informative graph. So there are some persons whose BMI is very high than the rest. So there are extreme observations. So the data is most likely does not follow normal distribution. Okay. Okay. Now there is one more plot called QQ plot, quantile plot. With the help of this also, we can study whether my data follows normal distribution or not. So this is the middle line. If these dots go side by side with the line, then we can say that my data follows normal distribution. If these dots is situated far from the line, then we say that my data does not follow normal distribution. Here, see, these data are situated far apart from this line. So in this case, there is less likely that my data follows normal distribution. In this case, most of the data follows go side by side with the line. So there is a possibility that, but some of the values are, some of the extreme observation are there also here. These are some extreme observations, but there is chances that this follows normal distribution. So I'll show you how to make QQ plot in SPS. So this is the QQ plot. It is also very informative curve. So for that, suppose I want to make a QQ plot for oh, 1 minute. Okay, suppose I want to make the QQ plot for the variable age. So for that, I have to go to and graphs, legacy dialog. Okay, then I have to go. Actually, we can do it here also. QQ plot can be constructed in analyze also. So for constructing QQ plot, I have to go to analyze, descriptive statistics. Then I have to go to explore. Okay, so analyze, descriptive statistics, and explore. Okay, analyze, descriptive statistics, explore. Click explore. Then I have to put the variable here, dependent list is. Suppose I want to construct the QQ plot for age. So I have to select age and put it in the dependent list. Okay. Then you have to go to plots. Okay. So histogram is there. You can calculate histogram with there. Then normality plots with test. You have to select this one. Normality plots with test. Okay. If you select this option, then also the Kolmogorov Smirnov test for testing the normality will also done with this option. Normality plot with test. So I will show you one more time. You have to go to analyze, descriptive statistics, explore. Okay. Select this. Then you have to select the variable for which you want to test the normality. Then go to dependent list. Then select plot. Okay, then select this normality plot with test. You can select histogram also. Histogram we have also already calculated, constructed. By using this explore option also you can construct the histogram. So continue. So this is the histogram. This is the QQ plot. Okay, this is the QQ plot. Okay, so you see the dots go side by side with the age variable. So there is a chance that my age variable follows a normal distribution. Okay, so I will show you with one other variable. So let us go to analyze, descriptive statistics, explore. Suppose I want to find it for income. So income has some extreme observation. From the box plot we have observed that income has some extreme observation. So select there, then go to plots, then normality plot with test, and continue. Okay. This is the histogram for income. This is the QQ plot. You see, here the values are separated from the line. Okay, some extreme observations are there. Because of that, data may not follow normal distribution. So these are the three plots with the help of which we can study the normality of the data. Okay. We can study the normality of the data. The first one is histogram. Then we have box plot. Then we have QQ plot. So by using this plot, we can have an idea about the normality of the data I have collected. Right now, actually you should use the statistical test for to get a concretive. This means to get a final conclusion, you should apply Kolmogorov-Smirnov test. Okay, so actually graph gives us an idea. From the graphs, we cannot actually say that my data follows normal distribution or not. Okay, graphs gives you an idea about it, but to get a final conclusion, you need to have the Kolmogorov-Smirnov test for testing the normality. Okay, so case tests are developed by these two mathematicians, Russians, and the hypothesis is that the data follows normal distribution. The null hypothesis is that my data follows normal distribution. The data I collected from the field follows normal distribution. That means there is no difference that my data and normal distribution are same. Okay, the data I have calculated is same as if I generate the data by using normal distribution are same. An alternative hypothesis is that the data does not follow normal distribution. We can set the null hypothesis in different way also, but this is the simplest way. Okay. So I am giving the simplest way of presenting the null hypothesis. We can state the null hypothesis in different terms also, in mathematical symbols also. But this is the simple way we can do it. For social science people, I think it is okay. So my null hypothesis is that data follows normal distribution, and alternative hypothesis is that my data does not follow normal distribution. And what is the decision rule? Reject H naught. We have to reject H naught. This null hypothesis if my p-value is less than 0.05. And we have to accept H naught if my p-value is greater than 0.05. This is the decision rule. Okay. We have to set a null hypothesis. We have set the null hypothesis that my data and the data generated for normal distribution are same. And alternative hypothesis is that the data does not follow normal distribution. And my decision rule is we reject this null hypothesis if my p-value is less than 0.05, less than or equal to 0.05, and accept H naught if my p-value is greater than 0.05. Okay. Now I'll show you how to do test by using SPS. So for that, I have to go to analyze. Suppose I am going to find test whether my age data, this age variable follows normal distribution or not. So for that, I have to go to analyze, go to descriptive statistics. Okay. So then explore. Okay. The same way, same process. Analyze, descriptive statistics, explore. Okay, then click. So I want to test the normality of age. Select age here. So plots we have already selected. So normality plot with test. So it will do this test also. Okay. If I select this one, then it will do the plotting and testing both. Right. So click continue. Click OK. One minute. I have to do it. So go to analyze, descriptive statistics, explore, then age. We have selected plots, normality plot with test, continue. Okay. So these are the descriptive statistics. This table is the descriptive statistics, and this is the table for statistical tests. You see, this is the Kolmogorov's mean of test. This is the Kolmogorov's mean of test. Okay. So you see, what is this SID means? This is the p-value. This is the p-value. Okay. This is the p-value. So what is the p-value? P-value is 0.000. That means it is less than 0.05. That means we have to reject our null hypothesis. That means my data does not follow normal distribution. That means what? From the box plot, we see that in age data there is no skewed observations, and in QQ plot also we see that my age data goes side by side with that middle line, vertical line, or that diagonal line. Sorry, diagonal line. But in test we confirm that my data actually does not follow normal distribution. From this you see here, your p-value is less than 0.05. That means it does not follow normal distribution. Okay. Okay. Let us try one more time with suppose another variable. So analyze. Suppose we want to find the Kolmogorov's mean of test for income, for the variable income. So go to income, select income, plots. It is already selected, normality plot with test. Continue. Okay. So you see here, you see the p-value, SIG means the p-value is less than 0.05. That means my data, we have to reject our null hypothesis that my data follows normal distribution. Actually, I have to accept the alternative hypothesis that my data does not follow normal distribution. Okay. So from this, we can very easily calculate. This is actually Kolmogorov mean of test is a huge calculation. With the help of SPSS, it can be done in seconds. So this is the advantage of using SPSS. Okay, it's a very popular test, and it involves a lot of calculations, right? So we can very easily test that my data does not follow normal distribution. So let us try for one more variable. Suppose let us do it for BMI, body mass index. Okay, so go to analyze, descriptive statistics, explore. So select BMI. It is already selected, normality plotted test, continue. Okay. What is the p-value here? P-value is here also p-value is pointless. You can see a lot of skewed variable, lot of extreme observation there in the box plot of BMI. So from the box plot also we can observe that this does not follow normal distribution, and this is confirmed by the Kolmogorov's mean of test that the p-value is less than 0.05, so it does not follow normal distribution. Okay, now based on this, we have to use parametric or non-parametric test. Okay, if now in all my datas we don't follow normal distribution. We have already tested by using Kolmogorov's mean of test. So now it does not follow normal distribution. So we have to apply non-parametric test. We cannot apply parametric test. Okay, so if I going to use parametric test, then it will not give us fruitful results. Okay, a lot of scholars use parametric tests without testing the normality of the data, and that does not give fruitful answers. Okay, good results. So you have, before using any statistical test, you first check your data whether it follows normal distribution or not. After that, you have to go for the proper statistical test. Now let us move to the statistical test. So let us first discuss the parametric test. So we are discussing here test for means. Okay, these are all parametric tests. Single sample t-test. Here we are testing the mean. Suppose I am collecting the information on marks of students of Dibrugarh University. So I have to calculate what? We have to calculate a value which can represent the marks. Okay, all the marks. Suppose there are 4,000 students in our university. So if our vice chancellor asks me about what type of marks our student is getting, so if I give him the list of all the students and their marks, he will not get any information from that. So I have to give some summary statistics, with the help of which he can understand what type of marks our students are getting. So one of the main summary statistics is the mean. So here, by using mean, we can give a summary, we can have an understanding about the data. So here I will show you the test for single sample t-test, independent sample t-test, or two sample t-test, pair t-test, dependent sample t-test, or one-way analysis of variance. I'll show you one by one how this can be done in SPS. So single sample t-test, you see the situation. So the one sample t-test or single sample t-test is a statistical procedure used to determine whether a sample of observation would have generated by a process with a specific mean. Suppose I want to check whether the data we have calculated belongs to a particular population or not. Suppose I have given an example. You see, we suppose that the population mean IQ of the students is 100. Suppose we know that from other source that mean IQ level of my students of Dibrugarh University is 100. Okay. Now we draw a random sample of size 30 from the school or university like this. Suppose this is for this IQ level is for school. Suppose we suppose it will be like this. Suppose the population mean IQ of the students of school students of Dibrugarh district is suppose 100. Okay. Suppose we draw a random sample of size 30 from a school and calculate the IQ levels of the selected sample. Suppose what we do, we conduct a test among the students. So we draw a random sample of 30 students from the school. Okay. So we draw a random sample of 30. Suppose that school has 500 students. So out of 500 students, we draw a random sample of 30 students and we conducted a intelligent quotient test. Okay. And calculated their IQ levels of all the students based on their answering pattern, answering marks they got from the test. Okay, using then we can now I know that the IQ level of the students, mean IQ level of the student population of the whole population is 100. Now by using single sample t-test, we can test whether our assumption that population mu IQ 100 is 100 or not. Now I can check by using the sample that whether the assumption we have considered an assumption that the mean IQ level is 100 of the students of this school. Okay, we assume that the mean IQ level of the students of this school is 100. Okay, now we have to check whether my assumption is true or false. So to do that, I have to draw a random sample of, suppose I have drawn a random sample of 30 and tested their IQ levels. And by using simple sample t-test, we can test whether our assumption that the population mean IQ is 100 or not. So we have to check whether my assumption, we have assumed that my mean IQ level is 100. So by using single sample t-test, we are going to test whether my assumption is true or false. Okay. So my null hypothesis is that null hypothesis means hypothesis of no difference. So here no difference. That means we have to assume that the population mean IQ level is 100. There is no. That means my assumption and the population mean IQ level is same. Okay. So alternative hypothesis is that the population mean is not equal to 100. So okay, you understand? I think everybody. Okay. Then what is the decision rule? Decision rule will be same. Reject H naught. We have to reject this H naught when p value is less than equal to 0.05 and accept H naught when p value is greater than 0.05. Okay. So let us try it in SPS. Okay. So I have entered some separate data. So this is the single sample t-test. Suppose this is the students. This is the students of the school, 30 students, and we conducted a test. And the first student gets 70 marks, second student gets 120 marks, third student gets 110 marks, fourth student gets 101, fifth got 88. So like this, we have marks of the 30 students that we selected randomly. Okay, so we have to enter in this like this in SPSS. Now, for testing the single sample t-test, I have to go to analyze. Okay. Then I have to go to compare means. Right. Go to analyze. Then compare means. Then single sample t-test. Okay. Click here. You see. This is the only variable we have here. So click this. Now here we have the test value. Here we have to put the test value. What will be our test value? Our test value, assumption value is, according to the null hypothesis, our assumption value is 100. So I put 100 here. Okay. Then click OK. It's done. So you see, what is the p value? What is the p value? This is the p value. 0.271. That means it is greater than 0.05. this. It falls in this here. It does this second line. This one. Except it's not if p-value is greater than 0.05. Okay. So it is greater than 0.05. Okay. So that means what? We have to accept the null hypothesis that the mean IQ level of the students is less than is equal to 100. Are you getting my point? So I will show you one more time. This is the curve. So here what we are testing. I will explain the situation one more time. Suppose I have a school. Okay. Now I consider that the IQ level of the students of the school is 100. This is my assumption. Now I have to check whether my assumption is true or false. So for that, what I'll do, I will take a random sample from the school and conducted a test on the students and collected their marks. And based on the marks, I have to test whether my assumption is true or false. And that can be done by using a single sample t-test. Suppose, so single sample t-test can be done by, so these are the marks of the students. And for conducting single sample t-test, I have to go to analyze, go to compare means, go to compare means, then single sample t-test. Okay. Select. It is already selected. So I have to put the test value here. So click OK. So this is greater than 0.05. So we have to accept our null hypothesis that my assumption is true. That means my assumption that the mean IQ level of the students of this school is 100 is true. Okay. So let us do it one more time by using this data. Suppose in my original database, this one. So I have a variable called systolic blood pressure. Okay. So actually these data are collected in Mizoram. Okay. These data are real data set. You see the name of the person, it is very unfamiliar, na? Because these are collected in Mizoram. Okay. Now from some previous study, I know that the mean systolic blood pressure of the people of Mizoram is 120. Okay. From previous study, I got the result that mean systolic blood pressure of the mean systolic blood pressure of the person of the individuals of residing in Mizoram are 120. So I have to check that whether this assumption is true or not with the help of my data. Okay. So I have to go to analyze. So what will be my null hypothesis? My null hypothesis is that the mean systolic blood pressure level of people of Mizoram is 120. Okay. And null have alternative hypothesis that it is not equal to 120. So go to compare means. So go to 120 single sample t-test. Then what will be my variable? My variable is systolic blood pressure. Put it here. Then test value is 120. You see what is the p value? P value is 0.000. That means it is less than 0.05. It is less than 0.05. That means what? We have to reject the null. This is a significant value. That means my assumption that the population, the mean population as mean systolic blood pressure of people of Mizoram is 120 is not true. Actually. Okay, the value that we got from the other study is not correct. Okay. So I think you understand what is single sample t-test. Now I will go for two sample t-test, the second one. This one is most widely used. In most of the situation, this can be used. independent sample t-test or two sample t-test. Independent means what? Independent means non-overlapping. Okay. So suppose I want to compare two groups of people. I want to compare some parameter of two groups of people. So it should be such that the member of one group of people cannot be a member to the other group. Okay, that is called non-overlapping. People of one group cannot be a member of the other group. That is called independent group. Both are non-overlapping. Okay. So suppose I want to test whether the marks of the male students are equal to the marks of the female students or not. I want to test it. So both the groups are independent, non-overlapping groups. So in that case, I have to use independent sample t-test or two sample t-test. Okay. So when we have two independent groups and I want to compare the means of both the groups, then I have to go for independent sample t-test. You see, situation it compares the means of two independent groups. Okay. Suppose we want to compare the IQ level of student of two schools. So I want to compare whether the IQ level of this school and this school are same or not. I want to check it. Or whether the IQ level of this school is more than this school, I want to compare. Okay. So in that case, I have to use independent sample test. So let a random sample of 15 students from each school are selected. Okay. So what we do to compare this, it is not possible to conduct a test for all the students of the school. So what we do, we take a random sample of 15 students from this school and both the schools, school 1 and school 2, and are selected, and the IQ levels is tested by using some intelligence test. So I calculate the IQ level of the selected sample of both the schools with the help of an intelligence test. Okay. From independent sample t-test, we can compare whether the IQ level of students of both the schools are same or not. Okay. So here, what will be my null hypothesis? I have given some other null hypothesis. So what will be the null hypothesis here? So this is not. So this is not the null hypothesis for this case. Okay. So this is for other case. I will explain it later. So this is not the null hypothesis. So for this case, what will be my null hypothesis? My null hypothesis is that the mean IQ level of both the school 1 and school 2 are same. There is no difference because it is a null hypothesis, no difference. So the mean IQ level of the students of school 1 and school 2 are same. So what we have to do, what will be the decision? Decision rule will be same. Reject H naught if p value is less than 0.05 or accept H naught when p value is greater than 0.05. So this is my decision. Okay. So let us do. Let us conduct this test in SPS. So suppose this is the marks of the school 1 and school 2. So this is the 15 students of school 1. These are the 15 students of school 2. And school 1, first student is getting 100, second student getting 88, third student getting 75, like this. Okay. This one. This is the marks of the two schools that we have got from the intelligence test. Okay. Now I have to use SPSS to compare whether the marks of school 1 and school 2 are same or not. For that, I have to go to analyze. Okay, one more thing. There is one more important thing in SPSS is that that arrangement of data is very important. Okay, the arrangement of data in SPSS is very important. So in some tests, you have to arrange the data in a particular way. Okay, in this test also, we have to arrange my data in a particular way. While conducting two sample t-tests, I cannot arrange the data like this. Okay, so we have to arrange the data in some particular way. So what is the particular way? So what we have to do, I have to copy this, and put it here. Okay, and I have to construct a new variable. So this is school 1, school 2. So new variable is supposed to identify. So to identify, we know that from 1 to 15, these are the marks of the school 1. And from 16 to 30, the school of the marks of the school 2. But the SPSS does not know this one. So I have to identify this, I need to create one variable. So variable is that, suppose I give a variable name as group. Okay. So group. So group, it will be a discrete variable. So I will give, I have to give codes. So suppose 0 for school 1, 0 for school 1, copy. So this 0 means suppose school 1 and 1 means school 2. Okay. So this is very, very important. You have to arrange the data like this to do independent sample t-test. Okay. Now what I did, I copied this data here, and to identify which group that this score belongs to, school 1 or school 2, I have to classify them with the help of a new variable and coded that is that 0 and 1. 0 means school 1 and 1 means school 2. Okay. Now we have to go to analyze. Now my data is ready for analysis. So now we have to go to analyze, then compare means, then independent sample t-test. Okay. Now this is the variable school 1. So put it here, test variable. Okay. Now you see there is one more variable, grouping variable. So this is the grouping variable, group. It's we have to show which group belongs to this. So click here. So define groups. So you have to click here. So there are two groups only, 0 and 1. Continue. So this is the result. Okay, I'll do one more. You see here, this is the descriptive statistics. This table gives us the descriptive statistics. 0 means school 1, 1 means school 2. That is actually what is this? This is the mean marks of the school 1 student. This is the mean marks of the school 2 student. That means mean marks of the school 2 students are more than mean marks of the school students of school of students of 1. Okay. Now let us do one more thing. Why it is coming at 0 and 1? Because I have not used the value levels. Okay. Yesterday I'll show you how to copy save the codes for the different categorical variables. So if I put this, I'll show you. So, okay. So this is my variable. So let us define the variables. So group, go to values. Yesterday I have shown you. Okay, define. So 0 means school 1. It will be easier for you if you define the codes here. And 1 for school 2. Okay. Then you have to go to analyze descriptive statistics. Oh, sorry. Compare means independent sample t-test. Then you go to, you put a school 1 here, grouping variable here. Okay, define. Now you see school 1 mean is this, school 2 mean is this. This is the advantage of saving the codes. Okay. And now let's go to this table. This is a very big table. So actually what happened, I don't know whether Hazarika sir tell you or not. Actually, t-test, two sample t-test has two formulas. Okay, two sample t-test has two different formulas. One formula is developed when the variances of the data are equal. Okay, and one formula is developed where the variances are not equal. So we have two different formulas for Now, for independent sample t-test, now we have to decide which formula we are going to use, equal variance formula or not equal variance formula. So for that, I have to first test whether my variances are equal or not. Okay, actually this portion is what? This portion is the same thing. It tested the equality of variances, whether my variances are equal or not. So for testing the equality of variances, we have to use F-test. You see F-test. So for testing the means, we have used t-test. For testing the variance, we have to use F-test. Okay. So they have conducted a F-test here to see which formula will be more appropriate, equal variance or not equal variance. So F-test is used to test the equality of variances, right? So you see, this is the test value and this is the p-value. So what is the p-value here? P-value is 0.777. Okay, that means what? That means what? It is more than 0.05. That means we have to, now what is the null hypothesis here? Null hypothesis is that variances are equal, and alternative hypothesis is that variances are not equal. For testing this, for testing this equality of variances, we have also to assume a null hypothesis. Okay, so what will be my null hypothesis? My null hypothesis is that variances are equal, and alternative hypothesis is that variances are not equal. Okay, so we have tested it. So what is the p-value? P-value is 0.777. That means it is more than 0.05. Okay, it is greater than 0.05. So we accept the null hypothesis. We accept the null hypothesis that variances are equal. That means this formula is more. 1 minute. That means, so see, this t-value, so there are two t-values, you see. There are two t-values. This one, this one a t-value, this is a t-value. This t-value is calculated based on equal assumption formula, by assuming that variances are equal. Here, in this t-value, first t-value is calculated by using the formula which assume equal variances, and this t-value does not consider equal variances. Now, from the F-test, we see that then we accept the null hypothesis. That means what? That the variances of both the groups are equal because it is more than 0.05. That means we have to accept the null hypothesis. Our null hypothesis is that the variances are equal. Okay, so what is this? That means we have to use this t-value, the first one, because why? Because we the null hypothesis is accepted as the p-value is more than 0.05. So we have to use equal variances assumed. So this is the t-value calculated by using the equal variances, right? So I have to consider this formula. So
Excuse me, sir.
Yes.
If you wish, you can take a break of 10 minutes.
After this.
Okay, sir, sure.
This I will take a break. Okay. So you see, so we have to take this one. So here you see the p-value is what? P-value is 0.001. Okay, p-value is 0.001. That means what? That we have to reject the null hypothesis. That means we consider that the IQ level of school 1 and school 2 are same. So here it is not true. We have to reject the null hypothesis. Okay, so this is the thing. So okay, let us take a break. After that, we will resume again.
Sure, sir. We'll be taking a break for 10 minutes. The participants, please do not leave the meeting. We will be back by 4:55. Please do not leave the meeting and come at 4:55. Sure. Sir, if you're ready, we can start.
Yes, yes.
Okay. Dear friends, I would like to request sir to take about the session and progress. Thank you. So you can
Okay.
go on. Yeah.
So this is the way you can test the equality of means of two different samples. Okay. So I will show you one more time with another example. Suppose suppose we have a variable here in the main database that we constructed yesterday. We have a variable called systolic blood pressure. Okay. Now I want to check whether now suppose I want to find the mean of systolic blood pressure. So what is the mean? Mean systolic blood pressure is, yesterday I think we have calculated it. Systolic blood pressure for mean. Go to statistics. I have already shown this to you. So mean systolic blood pressure is what? This one. It is. Oh no, this is not the actual variable. Okay. Analyze statistics. This is not the actual variable. Actually, this is the binary variable we created yesterday. So original variable is this one, systolic blood pressure. Okay. So it is 120.42. So mean systolic blood pressure is 124.42. Suppose I want to find it for male and female separately. So yesterday I have shown you that it can be done by using select cases. No? Yesterday I have shown you that it can be done by say at first I have to select all the males, then I have to calculate the mean, then I have to select the females, then I have to calculate the mean. But this can be done by using other option also. Okay, so I will show you how to do this. Go to analyze, go to compare means, then means. You see here we have a mean variable. Okay, so select means. Then dependent variable, we have to put the systolic blood pressure variable, and in independent, we have to put sex. Okay. Then you have to go to option. Now what statistic you need? You need, suppose I need mean and standard deviation and number of cases. If I need, suppose median, then you have to select median here. If you need standard error of mean, you have to select it, put it here like this. So right now I need only mean and standard deviation. So continue. Sex of the respondent. Mean is for male, the mean is 122.52. For female is 1184.53. So I will show you one more time. If this is the total, this is the overall, it consists of both male and female participants. So if I need to find it separately for male and female or separately for rural and urban people, then I have to go to compare means, then mean. Suppose I want to do it for place of residence, then I have to select it for residential status. Okay, click continue. You see, rural it is 120.47, for urban it is 120.57. This is the standard deviation. Okay, now I want to do it for male and female. So go to compare means, independent sample t-test, then systolic blood pressure. Sorry. First of all, let us do compare means. Systolic blood pressure, then sex. Okay, so you see, mean systolic blood pressure for male is 122.52. Okay, that means on the average, the male person have systolic blood pressure of 122, and for female it is 118. So you see, females, the mean systolic blood pressure of females is less than male. Okay, but this observation is got from only 300 observations. This is our sample size. So what we have observed is for 300 observations. Okay. Now we have to check whether this is true for the whole population or not. And for that, this is actually the generalization. We have to generalize our sample to the whole population. What we have seen in the sample is true or not for the whole population. We have to test. We have to generalize this by using statistical test. That is the main purpose of statistics. In statistics, what we do, we take a sample, and based on the sample, based on the information collected from the sample, we have to give interpretation about the whole population. So from this sample, what we observed that the male systolic blood pressure is more than female. Now we have to check whether this is true for the whole population or not. So for that, I have to go for a statistical test, independent sample t-test. Why independent sample? Because the people, there are two groups, one is male, one is female, and both group are non-overlapping. So a person from the male group cannot be a member of the female group. So it's a non-overlapping group. So I have to use independent sample t-test. So I have set the values. So this is the systolic blood pressure. This is the systolic blood pressure, and this is the coding variable, male and female. Okay, this is already there. Okay, so go to analyze, go to compare mean, independent sample t-test. So put systolic blood pressure, then grouping variable. Sex is the grouping variable. So we have to define the groups. So male is 0, female is 1. So 0, 1. Continue. So you see, this is the descriptive statistics table. Mean systolic blood pressure of male is 122. Mean systolic blood pressure for female is 118. Now you see, before getting which of the p value will take, we have to conduct another test, F test, for studying the equality of variances. Because I have already told you that there are two formulas for t-test, one for equal variances, one for not equal variances. So before using the actual formula, we have to check whether my variances are equal or not. So I have tested F test, and this is, you see, p value is 0.07. It is more than 0.05. Okay, it is more than 0.05. That means we have to accept our null hypothesis that my data follows normal. My data, the variances of the two groups are same. So what is my null hypothesis in this test? My null hypothesis is that the variances of both the groups are same. So as the p value is more than 0.05, so we accept it. Okay, right? So we accept the null hypothesis. So we have to use which test? Which one? So we have to use this one, because this is the formula based on equal variances. So we accept the null hypothesis. That means that variances of both the groups are equal. So we have to use this first formula, this formula. So this is the test. Okay. Now I'll show you how to present this one. So if you present all these things, then a lot of question may be arise. So you should not present all the things. Okay. So what I prefer to do, I actually modify this table. I club these two tables into one. So what I do, I actually prefer to copy it to Excel. In Excel, I do the modification. So there are a lot of things are given. So these things are not necessary actually. You need to give only those things which you can interpret. You can give the interpretation or write the conclusion. That things are important. Okay. So I don't prefer to give all the things. So I copy this. Sorry. So I copy this table. Okay. So mean standard error mean is not necessary. You can give it, no problem also. So number of observation is also not necessary. Most of the time we are not giving the number of observation. So, and we copy the second table. Okay. Below. Okay. So this all things are not necessary. So here we make 3 columns: t value, degrees of freedom, and p value. So give borders. Okay. Now t value, it is a small t, not capital T. Okay, so t value, so copy t value 2.135. So it is 2.135, and the user freedom is 298, and p value is 0.034. P value is whether it is accepted or rejected. It is rejected. That means the what will be our null hypothesis? Our null hypothesis is that the mean systolic blood pressure of male and female are same, but it is not true because it is p value is less than 0.05. So I have to copy it to Word because we have to write the reports in Word. Na? So at last I have to copy it to Word. I am showing you the way of presenting the data. We don't need to give all the things. Okay, don't need to give all the things. Only important things you should give. So this is the table. So this is the table, and what I can do, just erase this one because this is for both the groups. So this is the table. So this can be presented very easily. Now you see the mean systolic blood pressure for male is 122 and for female is 118. And it is rejected. The null hypothesis is rejected. That means what we have observed in the sample, it is also true for the whole population. That means the null hypothesis is rejected and it is true for both are not equal. That means male systolic blood pressure is more than female systolic blood pressure. As mentioned in the sample, we see that mean systolic blood pressure of male is more than female. Then we can conclude that in the population also, male systolic blood pressure is more than females. Okay. So let us go to the next. So this is how you can do a test for independent sample. This is a very widely used test. Now the next test. Dependent sample. This is also a two sample t-test, but here both the groups are dependent. In the previous test, both the groups are not independent, are independent, but here both the groups are dependent or related. We can call it related or dependent sample t-test. It is also called paired. Okay, the situation is that this inferential statistical test is used to determine whether the mean difference between two sets of pair observation is zero. That means the mean observation is zero means there is no difference. Both are equal. Huh? So if example, if I want to test whether the training is, if we want to test whether training is effective in increasing the memory capacity of students. Okay, so suppose I want to check whether the memory capacity of students will increase by training or not. Suppose whether a training is effective for increasing the increasing the memory capacity of students or not. Okay, so let us take a sample of 100 to 10 students and conduct a memory test before and after the training. Okay, the scores of both the tests are, and by using pair t-test, we compare the scores. Okay. Why it is called dependent sample t-test? Because it is also two samples. That means we have to take observation twice. Okay. So it is both the groups are related. That's why it is called two sample t-test. Okay. What is? Suppose I want to check whether training will help the students to increase the memory or not. I want to check it. So what I'll do, I'll take a random sample of students, 10 students suppose, and conduct a memory test. Okay, and write down their marks. Okay. Then after that, I give the training to them to increase the memory capacity. Okay, after completion of the training, I again conducted a test on memory and score. So I got two scores, no? One before the memory training program. One is after the training program. So I want to check whether the mean of both the groups are same or not. That if the means of both the groups are same, the training program does not have any influence on the influence on increasing the memory of the people. Okay, students. Okay, if you are getting my point, if the mean of the before training and after training are same, that means after training the scores are not increasing. That means it does not have, the training does not help the students to increase the memory. So that's why it is called a dependent sample test. That means why it is dependent, because we have to take uh, two observations from the same student in two different situations. First, before the test and after the test. Okay. From the same person, I have to collect information on two situations, before and after. That type of test is called dependent sample test. I can give you one more example. Suppose a new drug is discovered. Okay. Suppose a new drug is discovered for controlling the blood pressure. So we have to check whether that whether that medicine is effective or not, drug is effective or not. So what we do, we take a random sample and measure their blood pressure, and after measuring the blood pressure, I have given medicine to them, and after consumption of the medicine, we again collected their measurement of blood pressure. Okay, so we have taken blood pressure readings from the same person twice, before the medication, after medication, and now we have to compare it. Now, if the blood pressure level decreases after the medication, then the mean will decrease. That means if the mean of the before testing and after testing is different, then we can say that the drug is effective. Okay. Here we test what? Here we test whether the training is effective in increasing the memory capacity of students or not. I want to know whether the memory capacity of students increases after the training or not. So what we do, we take a random sample, take a random and conduct a test. And after conducting the test, we give the training about increasing the memory capacity, and after that we again conducted the test. So it is a called dependent sample test or related sample test, because we take observation from the same individual twice at two different situations. The mean score before training is equal to after training. Okay, and alternative hypothesis is that mean score before training is not equal to mean score alpha. So it is a null hypothesis. That means no difference. Mean score before training and mean score after training are same. And alternative hypothesis is that mean score before training is not equal to mean score after training. Okay, and what is the decision rule? Reject is not. The decision rule is same. Reject is not. Its p-value is less than equal to 0.05. Accept is not. Its p-value is greater than equal to 0.05. So let us conduct this by using SPS. So parity test. So this is the scores of 10 students before training and after training. Okay. So we have to arrange the data like this. We have to arrange the data in two columns, before training and after training. This is the score of the first student before training. This is the score of the students after training. It increases by 3. This is the score of the second student before training. This is the score of the second student after training. Okay. Now for conducting the parity test, we have to go to analyze, compare means, then parity test. Okay. Click parity test. Then select, you see, we have to put the variable 1 here, variable 2 here. So click before training and put before training there. This is the result. So this is the mean of before training is 7.6, after training is 8.88. And this is the standard deviation. and this is it will also give the correlation. Okay, so this is the mean before training, and this is the mean after training, and these are the standard deviations, right? And this is the correlation 0.85. Okay, and this is the p-value. Okay, p-value is 0.06, 0.206. That means what? That means what? That means it is more than 0.05. That means we have to accept the null hypothesis that before training mean score and after training mean score are same. That means what we can conclude from this test, we can conclude that the training does not help the student in increasing the memory, because the mean score before training and after training are same. It is not increasing. Okay, though in the sample the mean score increases, but for the whole population it is not increasing. Okay, this point in this sample you see for 7.6 and 8.8. So after training the score increases, but this is not true for the whole population. This is true for only 10 observers, 10 individuals. Okay, for the whole population the training is not effective. Okay, I'll show one more time. So this is the way we can arrange my data after before training and after training. Then go to analyze, compare means, parity test, then before and after training. So this is the result. So you don't need to present all the things. So I prefer to do like this. Go to Excel. So copy. Don't need standard error. Don't need number of observation. Delete it. Then you need only p-value, degrees of freedom, and p. Okay, you need this thing to make borders. Okay, then there is always an option to modify these tables. It gives a lot of information. Informations are important, but for presenting purpose, I think it is not very important. So this is the p-value, and this is the degrees of freedom 9, and this is the p-value. Okay, so this table can be very easily converted to Word, and you can present it. So from this table we see that though in the sample the mean score increases after training, but it is not true for the whole population, because the p-value is, from the p-value we accept the null hypothesis that the scores of both the situations are same. Okay, now let us go to another test. One-way analysis of variance. Okay, this is not a t-test, this is an f-test, but it also studies the mean. This is used to study the mean. Okay, now independent sample t-test is applied when we have only two independent groups. We have only two independent groups, suppose male or female. Suppose I want to compare the systolic blood pressure of male and female. Then we have to use independent sample t-test, because there are two groups only, male and female. For comparing the systolic blood pressure of suppose rural people and urban people, I have to use independent sample t-test, because there are only two groups. But if I have more than two groups, suppose I want to compare the systolic blood pressure level with education. So yesterday you saw that we have in education category, you have five different categories, huh? 5 different groups. One group is illiterate people, one group is primary education, one group is SSLC, one is HS, one is graduate. So how many groups we have? 4 or 5 groups. For that, I cannot use the independent sample t-test. Okay. For that, I have to go for one-way analysis of variance. That means what? When we have only two independent groups, I have to go for independent sample t-test. When I have more than two independent groups, then I have to go for one-way analysis of variance. Okay. So one-way analysis of variance is used to determine whether there are any statistically significant differences between means of three or more independent groups. Unrelated. Unrelated means independent. Okay. I read it one more time. That one-way analysis of variance is used to determine whether there are any statistical significant differences between the means of three or more independent groups. Okay, three or more. If two, then we cannot apply this method. We have to go for independent sample t-test. If three or more, then we have to apply. The main purpose is same, to compare the mean of unrelated group. Unrelated means independent group. Okay. Example, suppose we want to compare the IQ levels of students of class 10 of three schools. We draw a random sample of 10 students. Sample size of from each school may not be same from each school, and conducted the IQ test. Suppose I want to study whether the IQ level of class 10 students of three different schools are same or not. Okay, so there are three groups, right? So we cannot apply independent sample t-test. Okay, so what we do, we draw a random sample of 10 students from each school. And that numbers may not be equal. Okay, we can take a different sample size from each school also. Okay, and conducted a test. So what is the null hypothesis? Null hypothesis is that mean score of all the schools are same. Okay, null hypothesis means no difference. So there is no difference of IQ levels for all the students of all the schools. So alternative hypothesis is that mean score of at least two schools are not same. Okay, so mean score of IQ level of all the schools are same, and alternative hypothesis that mean score of at least two schools are not same, and the decision rule is same as always. Okay, so I have to apply one-way analysis of variance. So for that, so I have a separate data sheet. And so I have three schools. Okay, this is the sample of the first school 10 students. This is a sample of schools 10 students. This is a sample of third school 10 students. So this is the marks of the first school. This is the marks of the first school student, first student of the first school, second student of the first school, like this. I think you understand this. So go to analyze, compare means one-way ANOVA. Okay. Oh, okay. Here we also have to arrange the data in a particular way. Just like independent sample t-test. Okay. Here we have to arrange it. So copy these values, copy this here, and we have to put all the values in the same column. Okay. Now we need to have a grouping variable. Suppose group. Just like independent sample t-test. So first group I consider as one. This zero. Sorry, zero means suppose the first school, students of that first school. So for second school I put one. For third school I put two. Okay, it should be like this. So we should have two columns. In one column we'll have the marks of all the students, and in the second group, in the second variable, we have the group variable where we identify the students belongs to which group school. And then zero means the student belongs to first school, and one means it belongs to second school. You can put 1 to 3 also, no problem. And two means it belongs to the third school. Okay, you have for doing analysis of variance, you have to arrange the data in this pattern. Okay, then go to analyze, compare means one-way ANOVA. Then this is the variable. Here we have all the marks of all the school students. So click here, put it here. Then there is a variable called factor. So put group variable, go to factor, then option. You can give descriptive statistics. That means mean, median, mode will come. Put it here, continue. So this is the results. Okay. So let us do one more time. So you have to enter the data in this particular pattern. You have to give all the values of different groups into one column, and to identify data belongs to which group, you have to identify this by another variable like this. Then to analyze, compare mean, one way ANOVA. Then we have to put the variable here and grouping variable here. Then you can give descriptive statistics. Select descriptive statistics. Click OK. This is the okay. So this is the ANOVA table, one-way analysis of variance table. Okay, and this is the between sums of squares, within sums of squares. Okay, actually to understand this we need some theoretical class. So actually we need now we are doing it in SPSS, so I need only these two. The whether, so you see in this table, the mean score of the first school is what? Mean score of the first school is 79. Mean score of the second school is 64. Mean score of the third school is 60. That means here from the sample we see that the students of the first school is getting maximum marks, highest marks. It means 79. Then after that, second school is getting the second highest mark. Then the least third school is getting the least marks. Okay. Now we have to compare. We have to see whether this is true in the whole population or not. That means if I take all the students, this result is based on only 10 students from each school. So if whole population is what? All the students of the schools. Okay. So whether it is true for the whole students, if I take all the students, whether it is true, whether this result is true or not, I have to check it. So from our null hypothesis is that the mean score of all the groups are same, but it is not same here. Okay. Now we have to check whether this is true or not in the whole population. So p value is what? P value is 0.002. This is less than 0.05. That means what? That means we have to reject the null hypothesis that mean score of all the schools are same. That means we can consider that the mean score of the first school is highest than the others. Okay, getting my points? I think so. If we don't need to present all these things, just copy it to Excel. So copy. You can give this also, no problem. Confidence interval you can give. Maximum, minimum, I think it is not needed. Okay, confidence interval will give lot of information. It's a very important measure in statistics. So here we put F value, F test, and P value. Okay. Now number of observation is not required. Okay. So total is also not required. You can give, no problem. Then copy the other table. Okay. So F value is what? 0.48 this, and P value is less than 0.05, so we reject the null. So make it so, give the borders. Okay, so copy it to Word. Okay, this is the table. You can modify this table also, make it looks better. So this p-value is for all the groups. So I do what to do design. So this is the table. You can present like this. Okay, here we have to write like this. School one. Then it will be understandable for all. School two. School. Okay. So you can this rearrange the columns. Okay. So this is how you can present your data. You don't need to give all these. Otherwise, a lot of questions are going to arise. Okay. So we have in parametric test, we have conducted 4 tests: single sample t-test, independent sample t-test or 2 sample t-test, then pair t-test, and then one-way analysis of variance. These are all parametric tests. You have to apply this when your data follows normal distribution. If your data don't follow normal distribution, then we have to go for non-parametric test. So we have some non-parametric counterpart of this test. So single sample t-test, the non-parametric counterpart is sign test. Independent sample or 2 sample t-test, the non-parametric counterpart is man-with t-test. And pair t-test or dependent sample t-test, the non-parametric counterpart is Will-Cookson sign ring test. For analysis of variance, the non-parametric counterpart is Kuhl-Wallis test. So when you collect data, you first have to check its normal. If it follows normal distribution, then you have to go for parametric test. And if it does not follow normal distribution, then you have to go for non-parametric test. Okay. So I will show you how to do non-parametric test. The first one is sign test. Sign means sign, a plus, minus. It actually calculates the number of signs. Okay. So sign test is used to test the null hypothesis that the median. One more thing. When your data normal distribution when your data follows normal distribution, then mean is the better measure. So in yesterday, Hazarika sir told you about the measure of central tendency. Measure of central tendency gives us the central value of a data. Okay, it gives us about idea about the central value of the data. I have given you an example that suppose BC sir wants to know the marks of the students of our university. So what we do, I collect the marks of all the students and give the list to them. He will not have any idea about this. So if I say them that the mean marks is suppose 80. That means he can understand from that 80 that on the average our students are getting 80% marks. So that is the central value. So there are different measures of calculating the central value. First one is the arithmetic mean. Second one is the median. Third one is the mode. But now which one you are going to use? That is the most important thing. So why we have different measures? Why we don't have only mean? Because actually based on the data, mean all the measures have certain advantages and disadvantages. Okay, you have to use the proper method for at proper situations. Actually, mean is used when your data follows normal distribution, symmetric. If your data has some skewed value, extreme value, so in that case, mean is not a good measure. So non-parametric test is used when we have some extreme values. Now we have in the box plot, we have seen that we have extreme observation. That's why my data does not follow normal distribution. So when your data has extreme observation, so you cannot apply mean. Then you have to apply median. So in non-parametric test, median is the main focus. We have to focus on median, right? So in parametric, when your data follows normal distribution, you have to go for parametric test. Then mean is the proper measure. That's why the parametric tests are test for means. Now here we are not going to test the means. We are going to test the medians or ranks. Okay, non-parametric test is based on ranks and medians. Okay, this sign test is used to test the null hypothesis that median of a distribution is equal to some hypothesis below k. The situation is same here. Okay, in single sample t-test, the situation is that we have assumed one population value. We have assumed that the marks IQ level of the students is 100 of this school, and I have to test whether this is true or not. So the condition is same, but here we are studying the median IQ level, not the mean IQ level, right? So nine null hypothesis is that. So what is this? So sign test is used to test the null hypothesis that median of the distribution is equal to some hypothesis value. Hypothesis value means this is the value we assume. We assume that it is 100 like this. The test is based on the direction of the data and recorded the plus and minus sign. Okay, it shows the plus sign and minus sign rather than the numerical magnitude, and it is called sign test. Okay, so null hypothesis, the population median is equal to 100 and population median is not equal to 100, and the decision rule is same. Okay, so I use the same single sample t-test formula data to do this test because the situation is same. So this is the marks of the students. Now I have to check whether median IQ level is same or not. So for that, I have to go for non-parametric test. I have to go to analyze, then non-parametric test. Okay. Then I have to go to related samples. You can go to legacy dialog also. Okay. Legacy dialog. Okay. So we have to go to analyze, then non-parametric test, then legacy dialogs, then go to two related samples. Okay, actually this is a single sample t-test, but here we have to use two related samples. Okay, click. Okay. Before that, what we have to do, I have to put the assumed value here. Okay, so my assumed value is 100. We have to make it 2 because we are using two sample t-test, related two sample t-test, two related samples. So I need two samples. First sample is this, the original sample, and the second one is 100. So we are comparing this value with 100. So okay, now this is the, so go to analyze, non-parametric test, legacy dialog, two related samples. So you have to put IQ here and variables here. Then you see from the table, this is the table. So Z value is what? This is the Z value. Okay, Z value is the test statistics value, and this is the P value. This is the P value. Two-tail P value. Two-tail asymptotic significant value. So this is the P value is this. The P value is greater than 0.05. So we have to accept the null hypothesis that my the median IQ level of the students of this school is 100. So we have to accept it because the P value is more than 0.05. Right? I think not much time is not there. So I will show you quickly how to do the other test. Now, man-Whitney test. Man-Whitney test is used when we have two different independent groups. It is the non-parametric counterpart of two sample t-test. So two sample t-test when that your data follows norm when you have two groups and both are independent and it follows normal distribution, then you are going to use independent sample t-test. And if your data does not follow the normal distribution, you have to go for manual t-test. And the null hypothesis is that the population median of the two groups are same. In independent sample t-test, what was our null hypothesis? Our null hypothesis that the means of the two groups are same. Means of systolic blood pressure of male and female are same. Here, the null hypothesis is same, but it is based on medians. Population medians of the two groups are same, and the population medians of two groups are not same. And this is the reject the null hypothesis when we have p-value is less than 0.05 and accept when it's more than 0.05. Okay. So for independent sample t-test, I have to go to. So I have to arrange the data in the same way. In the first column, I have to put the value scores of all the two groups, and then in the second group, this variable I have to put the it's a binary variable which identifies the school. Okay, so go to analyze, go to non-parametric statistics, legacy dialog. You see two independent samples. Okay, click this. Then school one is this, and group is the same thing as independent sample details. So group 0 means school 1, group 1 means school 2. Fine. You see here. You see what is the two-tail t-test? This is the value. This is the value 0.003. This value is for two-tail and this is for one-tail. Now we are considering two-tail test. I don't want to go to the details for two-tail test. So this is the two-tail test value. Okay, because time is not there. So it's less than 0.05. That means we have to reject the null hypothesis that both the IQ level of school 1 and school 2 are same. That means they are not same, they are different. Okay. Then we have next test is Wilcoxon sign rank test. Wilcoxon sign rank test is the non-parametric counterpart of pair t-test or dependent sample t-test. When we have two related samples, I have already explained what is this. Suppose we are collecting, taking the IQ level of students before training and after training. They are related now. We are collecting the same information from the same person twice, but in different situation after some time. So in that case, if the data does not follow normal distribution, you have to use Wilcoxon sign rank test. So the null hypothesis will be same. The medians of the two related populations are equal. The median of the two related population are not equal. And this is the decision rule. And decision rule is same as always. So for two sample t-test, I have to, this is the pair t-test. I am using the same data. So data is same. So this is the before training of the students, scores of before training of the students, scores after training. So go to analyze, non-parametric statistics, legacy dialog, two related samples. Okay, two related samples. Then select before training, select this here after training, and Wilcoxon is there. So it is clicked. You see this, and this is the p-value. This is the p-value. P-value is 1.159. That means it is more than 0.05. That means we accept the null hypothesis that the median score of before training and after training are same. That means the training has no effect on increasing the memory capacity of the persons. So let us try the last one. Brusco-Wallis test. Brusco-Wallis test is the non-parametric counterpart of one-way analysis of variance. If we have more than two independent groups, then we have to use one-way analysis of variance. If it follows normal distribution. If it does not follow normal distribution, then we have to apply Brusco-Wallis test. Other things are same. The null hypothesis will be same. That means there is no difference in the excuse me. There is no difference. There is no difference in the medians of all the groups. All the groups have similar medians. Okay. All the groups, suppose we have more than two groups, all the groups have similar medians. And the null hypothesis is there. And alternative hypothesis is that there is some difference in the groups. Okay. So for that, I have to go to analyze. Sorry. I have a separate database for ANOVA, this one. So I have to arrange the data in the same way. In one column, I have to put all the values, and to identify that this value belongs to which group, I have to give a categorical variable. 0 means this belongs to one means belongs to school 2, and 2 means belongs to school 3, like this. So I have to go to analyze, non-parametric statistics, legacy dialog, then K independent samples. It may be 3 or more. That's why it is written as K. Okay. So school 1 we put here. Then grouping variable, you have to put in the grouping variable. Then define groups. So minimum is 0, maximum is 2. Continue. See, this is the result. So what is the interpretation? So p-value is less than 0.05. That means we reject the null hypothesis that the mean score of all the schools are similar. This is not true actually. So there is some difference in the mean score of all the students. Okay. So this is the all about parametric and non-parametric test. So I just want to say one thing, that before applying any statistical test, you should first check whether that data follows normal distribution or not. And for discrete data actually don't follow normal distribution. So for that, for discrete data, this all the tests we have discussed are for continuous data only. Okay, continuous data or ranks. For discrete data like male, female, 0, 1, education 1, 2, 3, 4, like this, we have different statistical tests, chi-square test, or we can use logistic regression like this. So we'll discuss it tomorrow with Hazarika sir. So I want to just say one thing, that before going for any statistical test, you please check the normality of the data. Then you go ahead. Then you get a you will get a fruitful result. Okay. Can we close? I think time is over. Huh? Hello.
Yes, sir. It's almost. It's almost, sir. Actually, participants, if you have any query, you can ask. Hello. Sir has discussed at length everything about descriptive statistics. And if you have any query, dear participants, please ask or type on the chat box. If you have any query, please type on the chat box so that we can read it out to Burman sir. Hello, sir.
Yes.
Yes, sir. Do you have anything to?
Yeah.
Sir, I think yeah, everyone is thanking you. It
Okay.
was a
Thank you.
very good and effective session.
Yes. Thank you. Thank you. Okay. Okay. And I think no question.
Sir,
Oh,
one question. Yes.
call
Can
one
you,
is.
sir, can you repeat crucial Wallis test again?
Okay. Okay. I'll show you one more. So Kushkalwali's test is applied we have when we have more than two groups, more than two independent groups, right? And both should be independent and the data should not follow normal distribution, right? So suppose I have three groups here, this one. Yes, I have marks of three. I have marks of. I have taken a random sample of 10 from three schools. This one, and from each school, I have to compare whether the marks of the students of all the groups are same or not. So for that, what I have to do, I have to first arrange the data in this pattern. Okay. First, I have to put all the values in one column, and to identify, I have to give a factor variable, and this 0 means first school, 1 means second school, 2 means third school. Okay. Then we have to go to analyze, non-parametric statistics, legacy dialog, then K independent samples. Okay, K independent samples means the samples should be independent, right? Not related. Then school. This is the school one. We have to put the test value here because I have put all the values in school one variable. Na? That's why I have to put this. And group variable, the identification variable I put here in grouping variable. And define range, I have to click define range. So I have to put the minimum value and the maximum value. Minimum is 0, means school 1. Maximum is 2, means school 3. Okay, continue. And I can also put click on options. Option, and I put we can give descriptive statistics. If I need the descriptive statistics also, you have to put it here. Okay, click OK. Click. So you can give that, you can make a table like this also, like suppose like this. Suppose this one. So first of all, what I do, I find the median. Compare means mean. Okay, go to analyze. Compare means. Okay, mean. I have already shown this to you. So school one, put it here. Grouping variable, put it here. Then option. I need median. Na? Median. So median is this one. Median. So this is the median. Okay. So copy is this median. Okay. And here we can give the Z value. This is the way of presenting the data. So these are the medians, because we are comparing the medians. That's why I am giving the medians. Then what will be the p value? P value is this. It's a chi-square test. So copy this here. Paste. So this is not Z. This is chi-square. Okay. So what is the value of chi-square? And this is p value. You can give the degree of freedom also. Then okay. So copy this to Word. So this is the way you can present. Okay, this is my style of presenting. You can change your style also. So I don't give all the values because lot of question can be arised in that case. So this is the, like this you can present it. Thank you. Any more questions?
Yes, yes, sir. One more question. Miss Oli Bora has asked, sir, can we put other variables in the dependent value while doing ANOVA or paired test? Suppose in ANOVA, can we put school to 2/3 as dependent variable?
No, no. Dependent variable means what? Dependent means suppose for which variable we are going to calculate the means. Okay. Or suppose I am going to calculate the systolic blood pressure of different groups. So in that case, my dependent variable will be the systolic blood pressure, not the groups. Group is the only to separate it. My original variable, dependent variable is systolic blood pressure. I have to separate the systolic blood pressure with respect to that groups. So I have to put like this. So the independent list, I have to put systolic blood pressure because this is my dependent variable. Okay, this is the main variable that I am going to study. And factor variable is to just to identify this systolic blood pressure belongs to which group. Suppose with respect to education, I want to see. So I have to select education and put it here.
Okay, sir. I hope the participants has got their answer. So I have one something else to ask you.
Yes.
Sir, you have done a study on performance COVID-19 pandemic and its recovery time of patients in India.
Yes.
So it's not within the purview of your lecture today, but still we want to hear from you a bit about it.
Okay, actually what we have used a statistical method here. This is called survival analysis, right? Survival
Okay, sir.
analysis or time to event analysis. It's a very interesting topic in statistics. It studies the time 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 taken to happening of an event. Suppose in my PhD thesis I studied the time required for a cancer patient to die from the beginning, from the diagnosis of the disease, how much time it requires to person to die. That means what is the survival of a person from diagnosis of the disease to the death. So this
Okay.
time event can be studied by using survival analysis. So by using in that paper, by using survival analysis, we have studied what is the median time, what is the average time of recovery of the patients, actually. And we got that for COVID-19 patient, the recovery time is 25 days.
Or in India
And
or
we
all
also
over?
compare it with Mace in India. In India.
Okay.
The
So very
25
interesting, really.
25 days. It requires 25 days, but we have not got much data.
Okay.
So we also compare it with respect to male and female. So we find that both the groups, male and female, require similar time for recovery.
Okay, sir. Thank you, sir. Any question, participants? I think there is no question. So thank you, sir. Once again, we'll meet again tomorrow in the morning session. You
Morning
along
session,
with,
which time?
yes, sir. A morning session at 10:30, sir.
10:30.
Yeah.
Okay. Thank you.
Thank you, sir. Once again, thank you, participants, for having a patience hearing. And we end up today. Tomorrow, sharply, the time will be announced in the Google Classroom. And sir, along with Professor Jiten Hazarika, sir, will join us for the final part of statistical programming in social sciences. Thank you, sir. Thank you.